So if I have an and statement, and I want to negate that statement, and of course by negation what we mean is a statement that's exactly the opposite in all situations. So let's just start with the and statement. P and Q just represents any two statements there, P, Q, but they're anded together. And so I'm going to think about the negation of that. What would that be? And like we've already stated, a negation of a statement is one that's opposite in all cases. And we know, we talked about negating just individual statements. Usually it's just putting the word not appropriately. But how does it work on a compound statement? How do we negate overall a compound statement? Well, let's look at it to make sure it's opposite in all cases. Let's look at the truth table here for the and statement, and then some different possibilities. So for P's and Q's, we got true, 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 false, false, true, false, false. And we know and, how does and work? They both have to be true for and to be true, right? So true and true here is true, true and false, they both have to be true for and to be true. So that one's false. False and true, so that's false. False and false is false. And so the negation of that is going to have exactly the opposite truth values. Well, you might be thinking, your first initial thought would be, let's just negate P, negate Q, see what happens. Well, let's go ahead and put, since we're negating them, let's go ahead and put their values underneath here. So negation of P is false, false, true, true. Negation of Q would be true, false, false, true, false, true. It is still though an and there, right? I didn't change that. So it still works the same way. False and false is false. Got to both be true. False and true is false. True and false is false. True and true is true. And so if we look at the results here, it's not exactly the opposite in all cases. It is in a couple of them, but not in all cases. The first case, the first line, it is opposite. The last line, it is opposite. But what about the middle two? It's not the opposite. So that's not the way you negate it. Turns out, if we look at negation P, negation Q, but we also do this, change that to or, let's see what happens there. So again, we have negation P, negation Q, so it's false, false, true, true. And negation Q is false, true, false, true. We've changed it to or, and so that changed things up because or is true when just one of them's true, right? So false or false is false, false or true is true, true or false is true, and true or true is true. And hey, look at that. Compared to the and statement there, that's exactly the opposite, isn't it? You got true, then you got false, false, and then you got true, false, and then you got true. It's exactly the opposite. So the moral of this story is, if I'm going to negate P and Q, I need to, that statement, I need to negate P, I need to negate Q, but then I also do what? Change the and over to or. Okay? So that's the little bit of trickiness in that. Not only do you negate the statements, but you also change the and to or. Now, if anything's going to be nice about this, what do you think this negation would be? If I got P or Q, what are you hoping then that is? Negate P, negate Q, change or to and, right? Yeah, and that's easy enough to verify here. Let's just do that real quick. So I got P or Q with the true, 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 false, false, true, false, false, all possible table here. So I'm ORing P or Q together now here, and so that's true or true is true. Again, OR is true if one of them is true. True or false is true. False or true is true. False or false is false. And so let's see if I change it to, for the negation, not P and not Q. So change the OR to and also. See what that does. So you got false, false, true, true, negation of P column. Negation of Q, just be the opposite of the Q's here, so that's false, true, true. But now I'm going to AND those together. And both of them have to be true, so it's false and false is false. False and true, true is false. True and false is false. True and true is true. So if we compare that to our OR statement there, is it exactly the opposite? In all cases, yes. So there is a little bit of justice there. So the negation of P or Q is not P and not Q. Okay? Now, we had one other compound statement. That was the if-then statement. If P, then Q. Or P arrow Q. Well, that one turns out to be the trickiest of the bunch. Yeah, it turns out to negate an if P then Q statement. You probably would never guess it, okay? Let's just look at it here. You're probably thinking, well, let's negate them, right? Do not P, arrow, not Q. Well, that if we check the truth table there, it doesn't work. That's not the negation. Matter of fact, you wind up to do the negation, you don't even negate one of those statements. And you change it to a completely different type of statement. You know, this is an if-then statement. Well, I guess we did that with these, but turns out to negate that, you're going to change it to an and statement, actually. So let me just show you how this works. So I've got P arrow Q. So let's put that in our truth table here. True, 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 false, false, true, false, false. Same old, same old. P arrow Q, so I got true arrow true is true. True arrow false, that's the only one that's false. False arrow true is true. And false arrow false is true. Well, take a look at this. And we could do this one, actually, we did that last time. We were talking about that's actually the, if you go back in your notes, you can look at, that's actually the inverse, isn't it? The inverse of this statement is when you negate both statements. That's called the inverse. Converse is when you flip it. Contrapositive when you flip and negate both of them. Both flip and negate. And we did a truth table for that, but if you go back and look at the inverse compared to the original statement, it's not negation. It's not the opposite in all cases. So check that out. Now it turns out to negate this, let's look at this statement. P and not Q. So P, don't negate P, negate Q, and change it to and. So that's true, true, false, false. Let's write the component values here. P is just a copy of the P column. Not Q, opposite of the Q column. So that's false, true, false, true. We're going to AND those together. And both of them have to be true to be true. True and false is false. True and true is true. False and false is false. And false and true, that's also false. And so look at those results. Exactly the opposite in each case. True, false, false, true, false, true, false. It's a dot, okay. So it turns out to negate the compound state, conditional statement, you do P and not Q. So it's a little tricky, a little bit tricky, but that's how it works. Okay? Yeah, so just again, note here, to negate if P then Q, I'm not going to negate P. P stays the same. I do negate the Q, so that makes sense. That probably doesn't make sense, but maybe it will once we do one here in a sentence here, an actual one. And then we change the if then to and. Okay, so that's how you negate an if P then Q statement. All right. So with these in mind, so that's our third one. So yeah, these two are pretty nice. That one's a little tricky. We'll do a couple examples here. Okay, so let's say I've got this thing. I play the banjo. And I cannot dance. So I want to do, for this, I want to do the negation of that. Well, I play the banjo and I cannot dance. Well, it's an and statement. So in the and statement, you just negate each component. So negate this. I do not play the banjo. So we negate that. Negate that, all right? I cannot dance. So how would I phrase it? Negation of I cannot dance. I can dance. Okay, take out the not there. And then to complete the negation, one last thing, change it to or. Yeah. And that's the easiest one to forget there. So that's how you negate and for that matter, very similar to negate the or statement. Negate the component statements, change the and over to or over to and, vice versa. All right? All right, so here's if I go to college. Then I learn logic. If I go to college, then I learn logic. All right, so the negation of that. Okay, so the if then, that's the tricky one here. If you've got an if P, I just erased it, but if P then Q statement, the negation of that is P and not Q. So for P, which here's P stays the same. I don't negate that. It's just P. So the negation is I go to college. The other thing to mention here that I've done since we've already kind of done it is I've left off if here. Why? Why did I leave the if off? Because I'm changing it to an and statement, right? There's not an if in an and statement. So that's the next thing. I go to college, I don't negate that, leave off the if, I'm changing it to and then I do negate the Q. So P stays P, but Q here, which is I learn logic, I change that to the negation of Q. So I do not learn logic. said, it's a little bit tricky there. P and not Q is the negation. Question? Yes?
So what if you have like, if Q then P? Do you negate Q or do you negate?
If Q then P?
Yeah,
If I do the negation of that?
yeah. Like, would you still negate Q or would you negate something?
Yeah, you keep the Q, so you do the negation of that. Keep the Q, negate the P, change it to and. Yeah, so it's the order, yeah. Whichever one's first, that's the one you don't negate. Right? Okay, now, another term here to mention, we'll do another one, but De Morgan's laws. Sometimes you'll see mention what are called De Morgan's laws. Well, De Morgan's laws, what they are, that's just the negations of the and the or statement. Just arranged, they're usually arranged in kind of a notational way. So De Morgan's laws, they're really just the negations of and or statements. Here's the way that you'll usually see these. The negation, parentheses, P and Q is equals not P or not Q. Do you see that's just what we just were saying? So I've got P and Q and I'm negating that statement. Well, the negation of P and Q is not P or not Q, right? That's what we just said. So it's just restating it kind of in a notational way here. And then the other De Morgan's law, negation, parentheses, P or Q, well, that's negation P and negation Q. So De Morgan's laws are really just what we were just saying, okay? So don't let that trip you up there. So I think, because I mentioned that because I think that's the way you may see these phrased using that term. Use De Morgan's laws to write the negation. I will take chemistry in the summer. This is the statement. I will take chemistry in the summer. Or I will not graduate. Use De Morgan's laws to write the negation of that. Well, De Morgan's laws are just the laws we talked about. How do we negate that? So it's exactly the same thing we're just doing. How do we negate this statement? Well, what kind of statement is it? It's an or statement. To negate an or statement, negate the component statements, change the or to and. So here's the component, that's P, that's our first component statement. Negate that. I will not take chemistry in the summer. Abbreviate there. I'm negating it, so let's go ahead and do it. To negate an or statement, you change the or to and. So it's and with that. Then you negate the Q statement here, which I will not graduate, the negation of that. Just take out the not there, I will graduate. So I will not take chemistry in the summer, and I will graduate. Okay? Question? So that's just, that's just the name, if you will, of those particular negations. All right. One more type of problem here. let's say I've got 4 statements. A is if it pours, it rains. B is if it doesn't pour, it doesn't rain. C is if it doesn't rain, it doesn't pour. And then D is it rains and it does not pour. Those 4 statements. Question number 1. Which is the logical negation of if it rains, it pours? Which one of those, A, B, C, or D? You're just randomly guessing, got a 25% shot here. Which is a logical negation of if it rains, it pours? Well, we probably, if we didn't know anything about it, we'd probably go with the one that has, or one of the ones that has these 2 parts negated. If it doesn't rain, it doesn't pour, so you may be thinking, well, it's C, or maybe B, or probably our first, if we didn't know anything about it, we'd probably guess C. C is not it, is it? How do we negate an if-then statement? If P, then Q. The negation of that is what? P and not Q. Which one of those is P and not Q? D. It's D. All right? The logical negation of if it rains and pours is D. It rains and it does not pour. And why? Because what I have is a worksheet that has a similar question to this, but not only tell me which one it is, but tell me why. Why is that the negation? That's really how you can say it. The negation of if P then Q is P and not Q. That's why. It's not negate both statements. That doesn't negate an if then statement, unfortunately. Okay? Question about that? So the second one then, which, and this goes back to actually something we talked about last time. Which of these, A, B, C, or D, is the logical equivalent to if it rains, it pours? Okay, so we changed our gears here because now we're looking for something that's exactly the same. Negation is the exact opposite. This D says the exact opposite of what that statement says. Now we're looking for a statement that says exactly the same thing, but in a little different way. If you're guessing, different people guess different ways. You know, this one has the same parts, just flipped around, right? These two, like I said, have negations to them. We know this one's not it, because that's the negation, that's the exact opposite. So we've narrowed it down to 3, haven't we? Which one is it? Well, what these other 3 are, those are, remember we talked about the converse, the inverse, and contrapositive? That's what these other 3 are, right? That's the flip of that statement, right? If it pours, it rains. we just flip those around, that's the converse. If it doesn't pour, it doesn't rain, that's the, that's flipped and negated, isn't it? So that's the contrapositive. If it doesn't rain, it doesn't pour, that's the, just negating those two statements, so that's the inverse. So, having said that, remember what we talked about at the very end last time. One of those is logically equivalent. Which one is it? It's the contrapositive, right? Yeah. If you have, let's B, since it is the contrapositive. Yeah. If you have an if-then statement, its contrapositive is always logically equivalent to itself. Okay, so if you flip and negate, remember the contrapositive is when you flip and negate the statement, that is the contrapositive, right? Yeah, because if it doesn't pour, that's the negation of the Q, and then if it and it doesn't rain, that's the negation of P. So that's, you see what I'm saying there? It's a contrapositive, and that is always logically equivalent. Okay. The other two are not logically equivalent to that statement. All right? Question or concern? So remember what we talked about. I don't think there was any problems in the last set that had that about the contrapositive being logically equivalent, but like I said, I have a worksheet, and it'll ask you about the contrapositive and, along with these negations as well. All right, any thoughts or concerns?